Imagine spending 2 years staring at 715,000 photographs of a dead ship, not casually looking, forensically studying, matching rivet to rivet, plate to plate, shadow to shadow, piecing together a puzzle where every piece weighs a secret that the ocean has been hiding for over 113 years. Now imagine that when you finally finish that puzzle, what stares back at you completely breaks everything you thought you understood about the most famous shipwreck in human history. That is exactly what happened when deep sea mapping company Magellan completed the most advanced underwater scanning project ever attempted on the Titanic. And what they found, 800 meters beneath the surface of the North Atlantic, was not just surprising, it was world-changing. It rewrote the final hours. It rescued the reputation of a man who had been wrongly accused for over a century. It gave physical proof of a sacrifice so enormous that most people have never even heard the names of the men who made it. And it revealed that everything the movies showed you, everything the official inquiries decided, everything your history teacher told you about how the Titanic died was missing the most important parts of the story. For most of the 113 years since Titanic sank on April 15, 1912, the wreck sitting at the bottom of the Atlantic was essentially unreachable in any meaningful scientific sense. Yes, expeditions visited it. Yes, Robert Ballard found it in 1985 lying in two pieces roughly 600 meters apart at a depth of about 3,800 meters, nearly 12,500 feet down, around 370 miles southeast of Newfoundland. Submersibles descended and filmed portions of it. Remotely operated vehicles captured hours of footage. Researchers collected artifacts and analyzed what little they could reach. But the full picture was always out of grasp. The darkness was too complete, the depth too extreme, the wreck too large, and the technology too limited to ever get a true view of the entire site at once. That limitation ended in 2022 when Magellan deployed two ROVs named Romeo and Juliet to the wreck site on a mission that no team had ever seriously attempted before. Not to visit Titanic, not to film highlights of it, but to completely map every single accessible surface of the ship and the surrounding debris field with millimeter-level accuracy. For 3 weeks straight, Romeo and Juliet descended each day, operating in precise coordinated patterns, photographing every angle, every corner, every broken edge, every scattered object across the debris field. By the time the expedition was complete, the team had captured 715,000 individual photographs, 16 terabytes of visual and spatial data. That is roughly equivalent to 6 million books worth of information, all of it focused on one ship on the bottom of the ocean. Back on the surface, the real work began. Advanced photogrammetry software processed those hundreds of thousands of overlapping geo-referenced images and used them to construct a complete three-dimensional model of the entire wreck site. The process took 2 years. 2 years of computation, analysis, reconstruction, and verification. But when it was finished, the world had something that had never existed before. A full-scale, one-to-one digital twin of the Titanic, accurate down to individual rivets. Researchers working with the project described walking alongside a life-size projection of it in a warehouse in London, zooming in on specific features, examining details that had never been visible before, experiencing the ship in a way that not even submersible crews could manage. Titanic analyst Parks Stevenson, who has studied the wreck for 20 years, said plainly that this was a genuine game-changer. For the first time in history, the entire truth of the wreck site could be examined in one place simultaneously, treated not as a romantic ruin, but as a crime scene. And when the forensic examination of that crime scene began, the discoveries came fast. The first and perhaps most visually striking revelation concerned the difference between the bow section and the stern section and what that difference actually meant. The bow, which contains roughly the first 450 feet of the ship, including the bridge, the forecourt, and the forward cargo holds, sits upright on the seafloor in a condition that researchers describe as remarkably intact. Over a century of submersion has obviously taken a toll. Bacterial colonies are slowly consuming the iron. Sections have collapsed. But structurally, the bow looks like something that used to be a ship. The railings are still there. The anchors are still in place. The portholes are still visible. You can look at it and recognize it. The stern section is something completely different. It is a compressed, folded, unrecognizable mass of twisted steel. Decks have pancaked inward. Plates are bent at angles that should not be physically possible. The entire structure looks less like the rear section of an ocean liner and more like a crushed can. For decades, the explanation was simple. The stern fell from the surface after the ship broke apart, hit the seafloor at high speed, and the impact destroyed it. That explanation was always somewhat uncomfortable because the bow section, which also fell and hit the seafloor, was in far better condition. But nobody had enough data to challenge the assumption with confidence. The 3D digital twin changed that. When researchers analyzed the damage patterns on the stern section with the precision that 715,000 photographs allow, they found something that fundamentally contradicted the impact theory. The damage pattern does not match a sudden collision with the seafloor. It matches progressive structural failure during descent. which means the stern was destroying itself on the way down, long before it ever reached the bottom. Here is what the scans revealed about what actually happened during those final minutes. When the iceberg damage caused the forward compartments to flood and the bow began pulling downward, the stern rose higher and higher out of the water. This placed enormous stress on the middle section of the ship, a point that the designers had actually tried to accommodate through expansion joints, which were meant to allow the hull to flex slightly in heavy seas. But those joints were never designed to handle the forces generated when one end of a 46,000-ton ship is being dragged underwater while the other end is pointing toward the sky at a steep and increasing angle. The keel began to bend, hull plates began separating, deck structures started tearing, and this was not a clean, sudden snap the way dozens of films have depicted it. This was progressive, grinding, agonizing structural disintegration that played out over several minutes, while people were still alive on that ship. The debris field provided the key forensic evidence for this conclusion. By mapping the exact position, orientation, and condition of thousands of individual pieces of wreckage scattered between the bow and stern, researchers could essentially read the breakup sequence like a story written in steel. Hull plates found in the debris showed evidence of being bent outward, not sheared cleanly, which indicates progressive failure rather than sudden fracture. Deck structures were pulled apart rather than snapped. Keel segments showed signs of twisting before separation. This is not the signature of a single catastrophic break. This is the signature of a ship that slowly tore itself apart over minutes, not seconds, while the stresses built and propagated in both directions from the weakest central point. When the bow section finally separated and began its plunge to the seafloor, the stern section, suddenly freed from the enormous weight pulling it down, actually settled back toward the water's surface briefly. Multiple survivors had described seeing this happen from their lifeboats. They were dismissed for decades. The digital twin confirms they were telling the truth. But the stern's brief moment of settling was the beginning of its final horror. It was already structurally weakened and fractured from the breakup. It was still partially buoyant because its compartments were not yet fully flooded. As it began its own descent, it carried internal air pockets that compressed under the increasing water pressure with every meter it sank. The ocean squeezed those air pockets, compartments imploded, decks collapsed inward on each other. The entire structure folded in on itself during the 2.5-mile journey to the seafloor, which at those depths becomes a compression chamber of almost unimaginable force. By the time the stern struck the bottom, it had already been crushed. The impact simply finished what the descent had started. This explains everything about why the stern looks so completely different from the bow. The bow sank with its compartments already flooded, equalizing pressure during the descent. The stern sank compromised and partially air-filled, and the ocean destroyed it on the way down. This revelation about the breakup sequence also does something historically important. It validates the eyewitness testimony that the official British inquiry after the disaster had refused to accept. For years after the sinking, survivors who said the ship had broken apart before disappearing beneath the surface were not believed. The official inquiry concluded that Titanic sank intact. Investigators and engineers of the time found it difficult to believe that a ship like Titanic could fail so catastrophically in its structure. So the survivors who had watched the ship from lifeboats, who described hearing the terrible sounds of metal tearing, who talked about the bow separating and the stern rising and then settling, who described the lights going out in sections as the ship broke, were questioned, doubted, and in some cases accused of letting trauma distort their memories. It was not until 1985 that the two-section wreck proved definitively that the survivors had been right. But the new digital twin goes much further than simply confirming the breakup. It confirms specific details that those survivors described, details specific enough that dismissing them as coincidence is not possible. The gradual bending rather than sudden snapping. The stern appearing to right itself briefly after separation. The lights staying on through the breakup and beyond. One by one, the details that seemed too specific or too dramatic to be reliable are being proven accurate by forensic evidence from 3,800 meters down. The survivors of the Titanic were telling the truth. They deserved to be believed decades earlier than they were. Now comes the part of the story that deserves far more attention than it has ever received. Not the captain, not the band, not the wealthy passengers, the engineers. When the iceberg struck Titanic at 11:40 p.m. on April 14, 1912, the engineering crew was deep in the machinery spaces of the ship. The boiler rooms, the engine rooms, the electrical generator spaces. These were already among the most brutal working environments imaginable, even on a calm night. Extreme heat from the furnaces, deafening noise, no natural light, the constant physical demands of feeding coal into fires and maintaining the massive systems that kept the ship moving and lit. These men were at the absolute bottom of the ship's social hierarchy. Their work was invisible to the passengers above them. Their names were largely unknown. And when disaster struck, they did something extraordinary. They did not run. They stayed. The digital twin provided physical evidence of exactly what they did, evidence that no previous expedition had been precise enough to capture. Researchers analyzing the scan identified a steam valve in the open position on the stern's deck, a position that corroborates accounts of engineers continuing to power the ship's electrical systems with steam right up until the final moments. More significantly, the boilers in the hull at the breaking point of the ship were found to be concave, meaning they were still pressurized and still running when the ship went under. Engineers and stokers had kept those furnaces burning as the ocean rose around them. They had kept the fires going and the generators running as the water crept upward in the darkness below the waterline. They did this for over 2 hours after the iceberg impact, staying at their posts in Boiler Room 2 while every instinct of self-preservation would have been screaming at them to get out. There were 35 men in that boiler room. Not one of them survived. Why does this matter beyond the obvious moral weight of it? Because those lights they kept burning were not just comfort. They were survival infrastructure for everyone else on that ship. Titanic struck the iceberg in the middle of the night. Without the ship's electrical lighting, the boat deck where the lifeboats were being loaded would have been in complete darkness. The davit motors that physically lowered the lifeboats down the side of the ship ran on electrical power. The wireless radio transmitter that was sending SOS signals to every ship within range ran on electrical power. The pumps working to slow the flooding of the forward compartments ran on electrical power. Every one of those functions depended on the generators running. And the generators ran because 35 men chose to die in a flooding, steaming, fire-lit boiler room, rather than abandon the post that was keeping everyone else alive. National Geographic's analysis of the findings suggests that the bravery of those engineers directly contributed to saving the more than 700 people who survived the disaster. If the lights had gone out an hour earlier, the evacuation in total darkness would have been catastrophically more chaotic. If the wireless had gone silent sooner, rescue ships might have arrived too late to save anyone at all. Every lifeboat that was successfully launched, every distress signal that reached the Carpathia, every minute that the evacuation remained organized rather than descending into blind panic was bought with the lives of men whose names most people have never heard. Chief Engineer Joseph Bell organized his department and kept them at their stations. All 25 of Titanic's engineers died. The broader engineering department, including stokers, trimmers, and electricians, lost men at a rate far exceeding the overall crew average. Their survival rate was devastating. These were men with families waiting for them, men who had no guarantee that their sacrifice would make any difference at all, men who chose it anyway. The open steam valve that Magellan's ROVs found and photographed with millimeter precision is physical proof of what they did. It is a piece of forensic evidence from the most important crime scene in maritime history, and it says more about human courage than any monument ever built for them. The digital twin also settled another controversy that has shadowed the Titanic story for over a century. First Officer William Murdoch, the officer on watch when the iceberg was spotted, who gave the fateful order to turn hard to starboard rather than turning into the iceberg directly, has been accused since 1912 of cowardice in the final moments. Multiple accounts allege that he shot passengers to maintain order on the boat deck, then shot himself rather than face the sinking. His reputation suffered enormously. His family in Scotland carried that stain for generations. The new scans may not be able to address what happened with specific passengers, but they resolved one key element of the accusations against him. The position of a lifeboat davit on the boat deck, captured with perfect accuracy in the 3D model, physically corroborates the testimony of crew members who said that Murdoch was actively working to launch a lifeboat when a wave washed across the deck and swept him into the ocean. He was not hiding, he was not running, he was doing his job until the sea took him. The physical evidence of where the davit was positioned, consistent with testimony that he had been operating it, gives reasonable weight to the conclusion that William Murdoch died at his post trying to save lives, not fleeing from his responsibility. The digital twin also captured the debris field in the kind of detail that transforms it from a scattered collection of wreckage into something far more moving. Scattered across the seafloor alongside the twisted steel are thousands of personal objects. Shoes, often found in pairs where bodies once lay before over a century of deep-sea conditions, erased any other trace of the people who wore them. Teacups and serving dishes from the dining saloons, personal luggage and trunks, a pocket watch whose hand stopped at the moment its owner entered the freezing water, a child's toy. The detail of the scan preserves these objects with the same precision it applies to structural analysis. You can see the individual stitching detail on a leather shoe. You can read the pattern on a ceramic plate. These are not artifacts in the clinical museum sense. They are the last physical traces of 1,117 people who went to the bottom of the Atlantic on a spring night in 1912 and never came back. Titanic was carrying approximately 2,224 people when it struck the iceberg. First-class passengers who had paid enormous sums for the privilege of crossing the Atlantic in luxury. Second-class travelers. Hundreds of third-class passengers. many of them immigrants from across Europe heading to America, carrying everything they owned in the bags that now lie scattered across 5 kilometers of ocean floor. Crew members from dozens of different departments, from the captain to the engine stokers to the kitchen staff to the musicians, all of them on the same ship, all of them meeting the same catastrophe, all of them reduced to equal status by the Atlantic. The scans also revealed the ongoing tragedy of what the wreck itself is facing. Iron-eating bacteria have been consuming the structure at an accelerating rate since 1985, when the wreck was discovered. The beautiful bow, with its visible railings and recognizable structure, will not look that way forever. Within decades, scientists estimate the Titanic may be reduced to a rust stain on the seafloor, with the bacteria finishing what 113 years of deep-sea conditions have started. The 3D digital twin preserves the wreck exactly as it appeared in 2022, accurate down to the rivet, in permanent digital form. Future generations who never have the opportunity to visit the physical site will still be able to examine the evidence, walk through the digital wreck, study the open steam valve and the concave boilers and the position of that davit, and understand what happened that night with a level of accuracy that was impossible for any previous generation. What the Magellan scan ultimately revealed is not just technical data about structural failure and hull damage. It is a picture of human beings under the most extreme pressure, imaginable, making choices that cost them everything. The engineering crew choosing their posts over the lifeboats, First Officer Murdoch working to save others until the sea claimed him, survivors watching from lifeboats with the accuracy of traumatized but honest witnesses, telling truths that the world refused to believe for decades. The Titanic was not just a ship that sank. It was a place where the absolute worst circumstances revealed the absolute best and worst of what human beings are capable of, and the physical evidence of those moments has been sitting undisturbed at the bottom of the Atlantic since April 15th, 1912. Now, for the first time in history, we can read that evidence clearly, not through film dramatizations or survivor accounts filtered through time and doubt and official inquiry, but through 715,000 photographs and 16 terabytes of data captured by 2 robots named Romeo and Juliet, processed over 2 years into a perfect digital replica of the most famous wreck in the world. The Titanic is gone, but its story, finally complete in ways it has never been before, is not going anywhere.